Okay, so we're going to talk about a couple new families today. I'm lumping them together. They're forms of alkanes and alkenes, but we have the word cyclo in front. So that tells us we're going to have a circle as part of the stem in these examples. So hydrocarbons can form ring structures. Often students ask me in yesterday's lesson whether this is possible, and I kind of just defer them to today when we deal with them. Obviously, you have to have at least 3 carbons to form a circle, so a cyclopropane is the smallest possible cyclo. Okay. When it comes to naming, IUPAC had to sort of make up a rule that everybody's going to follow because you don't have any ends anymore. If it's a circle, where do you start? Okay. So it's been decided that if there is a double bond, you have to put it in the 1 position by default, and that's how we're going to start. Otherwise, we'll start at whatever alkyl groups we have. So start at your double or triple bond first. If you don't have one, you'll start at any alkyl groups. If you got more than 1, you start alphabetic. So we'll kind of work through all of those possible scenarios, and it's only going to take us 2 slides to get through all of those. Okay. Largely, we're using the rules we learned yesterday. So I start with a simpler cyclo, and when I say simple, there's no double bond and there's no branches to this cyclo. I am using a condensed formula. I've condensed the H's in a little bit. So it's not fully condensed, but the H's are pulled in. I just keep mentioning this. If I ask you for a full structural diagram, you've got to draw all those H's out. I rarely do it on my board because it really clutters the diagram, and I think it hurts teaching. So we see the ring, and all of this ring is going to be my stem. So I have a circular snake-like pattern. There were no 3-way branches or 3 carbons coming off any 1 carbon. So I don't have to worry about alkyl groups. There's 1, 2, 3, 4, 5. So we're going to use pent. It's all single bonds. So it's a pentane. Okay. But those 5 carbons are in a circle, so we add cyclo in front of the stem. So it's a cyclopentane. Okay. Now we wouldn't go in and out of the ring, so this pent has to be just the ring part. We're going to see a branch in a second, and those will go in front of the cyclo just like they did before. So this is a simpler one. This is as hard as you're going to see in this course. Alberta Ed says I'm only allowed to put 2 things on a test question. For a homework or practice question, I can throw 4 or 5 in. I'm allowed to do that. But on a test or diploma, 2 is the limit. So this question has the double bond and alkyl group. So that's as confusing as it's going to get. Okay? So we went super easy and then to as hard as we can get. So we have a ring. If you have a ring, don't start counting in and out of the ring to get a longer chain. The ring is your stem by default. Okay, so don't count 1, 2, 3 and in and out. 1, 2, 3, 4, 5. So we have another pent. I see a double bond, so it's a pentene. Okay, it's a ring. So it's a cyclopentene. Now, the number here has to be a 1, but I don't need it because by definition, this has to be my first bond. Okay? We have to classify that the 1 position. That's what Okay, so we're kind of right in the middle. It's maybe the most important or complex part here. So we have to put the double bond in the 1 position. We've got to decide which way to go around the circle because we've got 2 choices. We've got to minimize the numbers. The key here is you have to go across the double bond when you decide which way to go. So one option would be to start 1, 2. So my carbons cross the double bond. 3, 4, 5. Okay, sorry, we'll hopefully get through this. Okay, so I've got to decide which way I want to go. So I pick this way first, 1, 2, 3, 4, 5. So I'm getting to the first branch on 3. If I go the other way, I'm not going to write this down because it's actually the wrong way. I'd have to start on this side, 1, 2, 3, 4 to get to the first alkyl group. So the shorter way to go across the double bond and hit the first alkyl group, I don't care what it is, methyl, ethyl, propyl, doesn't matter. Smallest number to get to an alkyl first is going this way. There's no rule that says you have to go clockwise or counterclockwise. You just have to minimize the number. Okay? So in this case, that's the red numbers are the correct numbers. So my methyls are in the 3 and the 4 position. So we have a 3,4 dimethyl cyclopentene. Hopefully I have enough room to fit that all in. 3, 4 dimethyl cyclopentene. I was hoping to squeeze that space out, but it doesn't want to let me slide it over. Okay. Questions about that? Sorry, you got interrupted twice. And again, and that's as mostly as difficult as it's going to get. Okay. Just a couple examples before I'll deal with multiple alkyl groups that aren't the same, and that's pretty much all you need to know. Or actually, sorry, that'll come up in later in the lesson. We can use line structures for cyclos. So I'm going to name this guy. I've drawn some line structures, but I haven't started with line structures and worked backwards. Does anybody see the cyclo name right off the bat? What would that be, Aaron? What is it? Is it? Perfect. Yeah, cyclobutane. So there are 4 carbons in that cyclo. If you don't see it right away, I encourage you to put a little circle at all the end of the line segments. Okay, so that's the proper line structure. I'm now manipulating. There's an end of a segment there, 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 and there. Okay. There's a carbon at the end of any line segment. Okay. So we have our cyclo here. And there's 4 of them with all single bonds. Okay. Now we've got to decide where to start our numbering. Okay. We don't have any double bonds, so we're going to have to just start at an alkyl group and try to minimize the numbers. So if I start here, I need to look at both ways. This is my 1, 2, 3. If I go that way, if I start here, 1, 2, 3, it didn't matter which way. I got a tie no matter which way I started. If I started here, it would still be 1, 3. So minimizing the numbers, it's a tie, 1, 3 dimethyl. Cyclobutane. One last one. Again, I'm going to do the question. Could I have started here? 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 No, there's nothing there. So you wouldn't start at a blank corner. If you do start here, you'd be like 2, 3, 4. So you get numbers of 2, 4, and that'd be wrong because 1, 3 is minimizing the numbers compared to 2, 4. So you're always trying to minimize the numbers and particularly minimizing that first number. If the first number is a tie, then you try to minimize the second number. So 2, 4 is not better. Yep. No, there's no always start on the right. You can start anywhere. Correct. And if you do there, it ends up being 1, 3 also. Now the bias, I'm standing on the right and I get to draw them. So, you know, I've got an inherent bias in how I draw them. But that's, you know, if I was teaching from over here, you might find me making the left the start more often. There's no rule that way. Okay. So just quickly circle all the line segments. Okay. As they get more confusing, it's really helpful to go back to those default skills or drawings that I encourage you to do. I'm going to circle the stem part. By circling that, I've clearly lit, you know, that green circle is definitely part of the stem, which leaves a 2-carbon chain there and a 1-carbon chain there. So we have another cyclo butane. Now I've got to decide how I'm going to minimize the numbers, and it's going to be 1, 2, 3, 1, 3, or if I start here, 1, 2, 3. So it's 1, 3 no matter where I start, but it's like, which one do I start at? And I'm going to start at whatever one comes first, alphabetic. So we've got meth and prop. So which one's going to come first? Sorry, you're right. I'm meth and F. So E is going to come before M. So I'm going to start with this guy. So that's going to be my 1. And it's going to be a tie no matter which way I go around the circle. It's going to be 1, 3 no matter which way I go. So we have 1 dash. I need to go number to letter. 1 ethyl. Now I've got to do the methyl. I'm going to transition, put another dash because I'm going to a number. 3 1 ethyl 3 methyl cyclobutane. And that's our cyclo sort of taken care of. I'm going to switch gears or topics a little bit and talk about some pattern recognition with all the 5 families we've gone through so far. So the anes, the enes, the ynes, the cycloanes, and the cycloenes. And these are referred to as generic formulas. So we're going to look at patterns. Now, one thing I haven't written up is anytime I'm referring to something with a double or single bond, I'm referring to there being just one of them. Okay. So this doesn't work. If you had 3 double bonds, this isn't true. If you have 1 double bond or 1 triple, so if you have any alkane, it's going to follow the pattern Cn, where n can be any whole number. The H count will always be double the carbon count plus 2. Now that's coming from all the middle carbons have 2 H's, and then the N carbons have an extra 1 on each end. And this plus 2 adds the extra carbon that's on each end, more than 2. So an example of this, if I have propane, C3, and it's an ane, I can quickly predict the hydrogen count. Two times 3 is 6, plus 2 is 8. I don't have to draw it to know the molecular formula. I can just quickly predict it. And this can be quite handy and useful. And I also want to highlight with all these families whether they're saturated or not. So what do you think about these alkanes and talking about saturation yesterday, Valentina? They are saturated. You cannot get any more hydrogen onto a hydrocarbon than an alkane. Okay? There's no double or triple bonds. Okay? If we move to an alkene, okay, again, as long as there's just one double bond. If we have a C3 again, I can quickly predict the H count. It's just going to be double. Okay? We lost two H's to put in the double bond. So it's going to be C3H6. Okay? And now this is unsaturated. Okay? Another way to think of whether something is saturated or not, going back to Chem 20 AP, is if there's any pi bonds, it's unsaturated. Okay? That double bond or the triple bond has a pi bond in it. Okay? If we have an alkyne with one triple bond, I want to keep using C3s, it's going to be 2n minus 2. So 6 minus 2, there will only be 4 H's. And this is also unsaturated. We can keep applying this to cycloalkanes. Now, the cyclo, it's still an ane, but it has a different generic formula. When you take an ane and you connect it into a ring, you have to lose an H at each end in order to make that connection. So a cycloalkane, Cn is H, it's just 2n. The plus 2 is gone. So if I had the smallest ring I could, a C3, there would only be 6 H's. Every carbon would have 2, 2, 4, 6. Okay? This is still saturated. Okay? Okay. There's no double or triple bonds. You can't add any more hydrogen to the cyclo. And then a cycloalkene, if you make an ene into a ring, it's 2n minus 2. Okay. It's got a double bond. You could destroy that double bond and add hydrogen to it. And we'll look at those type of reactions later this week when we get into the reaction section. This course starts with families and naming, and then once we go through all the families and learn all the naming rules, we'll start doing chemical reactions and turning one family into another. Okay. So you'll notice some overlap, and that's going to directly connect to the next skill we're going to use. We'll start with alkanes. Okay. Is there any other family that has the same pattern as an alkane? No, they kind of sit by themselves. If you have a molecular formula that tells you it's going to be an alkane, there's nothing else it could be. Okay? And that's kind of where we're going next. What if I told you you had a C50H100? What could that be? Okay? If you look at this pattern, well, that's the 100 is double 50. So this would be like a CnH2n type of pattern. And we want to figure out what could it be. Okay? If you have a 2n plus 2 pattern, it has to be all single bonds. It can't be a ring. It's impossible to have a 2n plus 2 and be in a ring. What about alkenes? That generic formula, does it overlap with any other family? Yeah, which one? Yeah. Okay. And that's kind of what we're seeing here. This is a CnH2n. Okay, and if you're wondering, well, how many ways could you draw this? What are the possibilities? It could have a double bond, or it could be a big ring. Either one is possible. Okay? But there's no way there's a triple bond here. Okay? It would have to be 98 in order for there to be a triple bond. Okay? And this leaves 2 left. They have the same pattern. Something with a triple bond has the same molecular formula as something that has a triple. Sorry, is a cyclo and has a double. So the triple bond or a ring with a double bond have the same formulas. Okay. And this leads into isomers. So I'm going to give you the definition, and then we're going to predict how many different ways can a molecular formula exist. So isomers are different molecules, and you may not be sure if a molecule is different. It could be just rotated, but you know it's different when it has a different name. That's going to come up a lot. You're going to see two structures. You're not sure if they're the same. Name them. Isomers, different molecules, but they have the same molecular formula. And I'm going to illustrate this by drawing all the isomers of C4H8. Now, I'm going to write something. I don't want you to write it down. I just want to illustrate something that is not different. Okay? I'm going to use a line structure. Okay? There's a cyclobutane. I'll make it methyl cyclobutane. What is this guy? Methyl cyclobutane. This guy and that guy are exactly the same. They're the same molecule. One's just rotated. Let's see if I can actually, yeah, I can rotate it. Okay. It's the same thing. It doesn't magically become something different just because it's a rotation of something else. Okay. And this is something that students can find confused. You have to make sure you don't get tricked by that. Something that looks different, but it isn't. It's just a rotation. Okay. Okay. So I'm going to draw all the isomers of C4H8. Well, this is essential. You can't do this question and finish a test if you're considering all 5 possibilities. The test will be done and you'll still be going through them. You need to be very systematic. What families should we be looking at, knowing it's C4H8? Okay. Sorry, just perfect. It just, this mass thing and questioning hurts, and they're very similar words. Perfect. So it's a CnH2n, so 8 is perfectly double 4. So we should only be trying to draw enes or cycloanes. There's no way there's a triple bond there. It just doesn't follow the pattern. That's a waste of time. Trying to draw enes from C4H8 is a total waste of time. It's impossible. You're wasting time on a diploma or test that you just don't have. Okay. So I'm going to draw all the enes I can do first. Once I've done all the enes, then I'll see how many cycloanes I can do. Okay. And then I'll have them all. Okay. I like to do this very systematically. So I like to start with the longest stem, do all of those, and then I'll go 1 unit smaller and 1 unit smaller and 1 unit smaller until nothing is possible. So that's how I'm going to approach all of these. Big stem down. C4H8, nothing says all 4 of those carbons are in a row. There just has to be 4. Okay? It could be a butane, could be a propane with a branch, could be an ethane with 2 or ethene with 2 branches. Okay? They're not all necessarily in a line. But that's where I'll start. My 4 carbons. To C4, I know I have to do an ene, so I'll put the double bond in the very first position. And then I'll put in my H's, and there better be 8. There has to be 8 or I've messed up. Now I'm counting to 4 around every carbon. A carbon has to have 4 bonds. For students and even for a teacher rushing, it's very easy to put too many bonds when you've got a double bond and you're rushing, it's easy to throw in 5 bonds around it if you're not being careful. Okay. So this is a bute. Okay. Very first carbon-carbon bond is a double. That's a but1-ene. So that's my first isomer of C4H8. Are there any other straight 4-carbon long enes that I can draw before I move down to 3 long? Yeah, perfect. I could do a but2-ene. Okay. And now I'm going to put the double bond in the middle. Can I keep going? Would there be a but3-ene? No. Why not a but3-ene? You're right that we can't do it. I don't love your wording of your explanation, Valentin. Yeah, you're not minimizing the number. The but3-ene is kind of more like your but1-ene named wrong. If we start counting here, first bond, second bond, third bond. So this kind of looks like a but3-ene, but it's naming from the wrong end. It's not minimizing the number. So you can only ever have the double bond from one end to the middle. Okay? So sort of halfway. So we have no more 4-carbon long chains with a double bond in it. Okay? So I've done all the 4 long. Next, let's see, can I put 3 in a row with a double bond, and now I've got to branch off the extra carbon. Now for the branch, I can't put my branch at the beginning because that would still be a but. I can't put it at the end. It would be part of the longest chain. The only spot I can put the 4th carbon is off the middle. And then my stem has to have a double bond in it. And it looks like everything's working out. Let's see, this carbon has 4 bonds already, so no H's there. And that's worked out. I got bonding capacity. I've used 4 carbons, 8 H's. I got an ene. This is a tricky one to name. I'd encourage you to take a few seconds. Does anybody want to make a stab at this? This pushes all the rules. I'll let Dave do it. I'm just giving people some thinking time. You want to say that again? You are right. So that is a methyl. He didn't say a number, and he's correct because it has to be in the 2 position. Can't be in the 1, can't be in the 3, so you don't need the 2 in front. Okay. The stem, which I think it really helps to circle, is a propene. It's a prop1-ene, but you're not allowed to put the double bond here. It's still prop1-ene. So there's only one possible spot to put that double bond. And so you drop that number also. So you don't need any numbers at all. Methyl propene. Is that what you're going to say too? And you'll find that there's no other enes that I can draw. Okay? I can't move the methyl group anywhere. I can't move the double bond anywhere. If I try to go down to 2 carbons with a double bond and try to put 2 branches, I can't. There's no middle to branch off. So I am done with my enes. There were 3 enes. I'm not done the question, but I'm sort of halfway. Now I've got to tackle the cyclos. Hopefully it makes sense. If you just try guessing and checking, you're never going to get a question like this right. Unknowingly on your diploma, since there's no drawing, the question will be C4H8, how many isomers are there? 4, 5, 6, or 7? And if you miss one, you get the wrong answer and you get no points. That's the way it is. I'm not saying I like it, but that's the way your diploma will be. You've got to get them all, so you've got to be systematic. Cycloanes. So again, I start my systematic. Start big, get small. So the biggest would be 4 in a circle. Cyclobutane. Once I've done my only 4-membered cyclo, I'll go down to 3 in the ring. So there's a cyclopropane. And then it doesn't matter where I put that methyl off. I could have put it down here, but it would just be a rotation to down there. Okay. I'm doing a methyl cyclopropane. I don't need a number because that methyl would be in the 1 position. So I can't move the methyl around, it'd still be in the 1 position, and I can't do a 2-carbon long ring. That's just doesn't make sense. So that's it. The answer to this question of the how many would be 5, and I've drawn all 5 of those isomers using the generic formulas to guide me. So I'm going to pause there. I want to give you a little bit of time in class to work. I'm going to give you some practice, but I'm not giving you enough time to finish all of that.